This is likely to be the second part of the video now. A class carries out an experiment to study heat transfer in solids and liquids. Explain why the coloured water moves the way it does. So for this, you've got to get densities in. As the water is heated by here, it expands and its volume increases, so the density decreases. So it's moving up. I should have put that there at the end, so it rises. I forgot to put that there. So it does rise. The cooling water, its volume decreases, so the density increases. Now, you don't have to mention the volume of water. If you just put the density increases, it's fine. Causing a convection current. So this is going to sink. So if I want you to get anything from this, is that as the particles, or as the water gets less dense, it's going to move up. And it's going to displace the more dense particles at the top. They're going to sink to the bottom. Then we've got this investigation here where they do the different metals. And this was a 6 marker. So, explain in detail why the process of conduction in copper in terms of the motion of particles. So I said the particles at the high temperature end gain kinetic energy from that flame. And they start to vibrate with increasing kinetic energy, it's movement energy. They will transfer this energy onto neighbouring particles by collisions, and they will continue through the body of the material. Okay, it's going to keep going. Copper has these free delocalized electrons, which gain energy at the warm end, and they are going to migrate towards the colder end, transferring energy more quickly. This is definitely going to come up somehow, even if it's not a 6 marker. You need to know how conduction happens, and in terms of the particle theory, where they do pass that kinetic energy on. This, a numeracy question, a lot of information going on here, a lot of information. I like the way they've done big dots here and then just small dots. I don't know what that's all about because they're all nuclear. You just need to recognize a trend here now for coal. Coal is at the dark region. You can see it reduces. Gas kind of remains, if anything, it's increasing. Your nuclear, pretty constant throughout the size. And I'm looking at the size of these, and it's only estimations. I'm not going to take my time. And, you know, there's ways to calculate these, but I'm not going to. It's all by eye. You can see my oil, the peaks at the top, they're all pretty constant. Renewable energy does increase slightly, I would say, from there to there. And by knowing all that, by working all that out, I can gain 3 marks just by stating the general trend in the use of fossil fuels over the period. There's a downward trend. It starts to reduce. Significant decrease in coal, which I talked about. There's a slight increase in gas. Oil remains stable, constant. I could have mentioned nuclear. So there's lots of things we could have talked about there for 3 marks. The use of nuclear fuels in the production of electricity between quarter 1, 2013 and quarter 1, 2016 remain roughly constant. Suggest possible reasons for this. This is a tough question because I didn't know this until I looked at the mark scheme. But nuclear power stations run all of the time, and no new nuclear power stations were set up in that period. That's a really vague question, I believe anyway. I don't think the question is really clear, if I'm honest. Production of electricity for blah, blah, blah. Well, this is basically saying why did wind drop? And it could be less windy or good weather. It could have been sunnier. Describe how the weather conditions were different. Look, why we had that reduction. And then the last question. Ooh, this is a big one. They will hide information from you in odd places. I know it's not hiding, but I didn't see that first time. There's so much information, and you've really got to invest heavily here to what they want from the question. This one, calculate the targeted percentage drop from all sources between 1990 from here to 2000. From 1990 from here to 2022, which is here. So I know my emissions here was 3900, okay, in 1990. My emissions in 2022 was 2544. Now, to see that percentage difference, Step 1, you've got to find the difference between these two first. Okay, so 2544 minus, 3900 minus that, give me 1356. And then step 2, you divide the increase, or you divide the big number by the small number by the bigger number. So you divide that increase, because it's going to be a percentage. The smaller's got to go on top over the original, and then you're going to come up with 35% when I times that by 100. Okay, so tough bit of numeracy there. Which they will, and they've thrown that up in 2017 as well, a question like that. On the very first question, there was a percentage increase. So you just got to know to take one from the other and then divide the small one by the big one. And then between 1990 and 2002, the main percentage dropped, blah, blah, blah. When you read the question, I said there's good progress being made because 40% in 2002 leads to 50% in 2027. But for 2 marks... and that's the paper. It's a tough paper. The grade boundaries on this at the time were, if you were getting 10 marks from 60, you were on for a C. So you can see it was a tough paper, but totally doable.